Okay, so hi everybody. My name is Rob Maines. I am the general manager of CHIPS Alliance, and it's a pleasure to be here today. And I'm going to chat a little bit about building the open hardware ecosystem and how we can do that, and also increase diversity in our workforce. So I call it from foundation to worktop to rooftops, because that's really is what it's about. So if we look at the industry that we have, it's exploding in terms of chips, if you will, right? It literally is, that is the case. And we see that in terms of the supply side shortage that's occurring because of challenges in the semiconductor space about, meeting the demand that's occurring across the industry, whether it be from your car or from your toaster oven in your house. There are many different things. And of course, with the development of 5G communication as the next generation communication protocol, that's going to further increase that explosion of things, because IoT is definitely a thing now, providing many sources of data and also communication attributes. So there's going to be just a huge number of chips, estimated in this chart that IBM provided, up to about 100 billion in 2050. And what does this really say? It says that, we're going to need engineering talent to help make this happen. The current quantity of engineers just is not sufficient enough to help sustain this. If we go on to the next chart, we do see many different compute and design challenges, right? Of course, the cost of hardware is increasing significantly, particularly for the advanced nodes. We're talking millions of dollars for a particular tape out of a given chip, right? So, you want to make sure it's right when it does go out, and then you're talking about quite a bit of time for that to actually be manufactured and happen. So there's no doubt that cost is increasing, but we're also seeing that innovation is stalled at corporate infrastructures. I think as the talk at CXL just exhibited, right, that there still are different proprietary type of implementations, particularly in the bus structure, as was mentioned, and related to memory bandwidth, but that's also the case in other areas too. And we're also seeing a need for more purpose-built architectures, whether that be machine learning type of things or a database accelerator, you name it, there are different types of special types of chips. So, in summary, from, years back when a given company basically had everything in-house, what I call soup to nuts, where all the way from the architecture to the process technology, EDA tooling, the design, and the construction of the chip, and then the system, that has really kind of changed to what more of has been of recent, a supply management type of thing, where a company is relying upon different partners, whether that be EDA or a foundry. And now we're definitely moving towards a new arena called what I call open collaboration, where you have different companies coming together to collaborate on different things of interest. So what CHIPS Alliance is about really is to provide that table, that dining room table, if you will, where different folks can come together and discuss ideas and work on different mutual shared goals, whether that be in terms of architecture, specification, implementation, reference implementation, such as in verification or in the physical implementation, tools, and verification, as I said. So CHIPS itself is part of the Linux Foundation. We do welcome IP contribution, but of course you don't have to provide that to join, and really the participation level is up to you. And so to date, we have 38 different member companies that are part of it, and it is certainly growing. Now, what CHIPS is really after, or one of its main goals, is what I call concentric collaborative innovation, right? Which is effectively building an open design ecosystem from specification all the way out through standards. And that includes things such as RTL, PDK, tooling, the PHY. So effectively, it's opening up what I call Pandora's box. There's really no mysteries here, that a given engineer can see the entire part of the ecosystem, which is something different and unique than what historically has been the case. So it allows a broader view of things, and as a result also encourages innovation, because going back to our, the talk that Kim just gave, right, is that by including more people of different backgrounds and encouraging a diverse ecosystem across the board, this will allow for more innovation in what we're seeing. And just curiously, I got this chart, courtesy of Skywater and Google. So, having run an engineering organization where we developed our own PDK, part of me when I first heard about this was that, well, who really is interested in an open source PDK? Well, it turns out a huge number of people are, and they're people from all different walks of life or different backgrounds. And as you can see in this chart from the orange line there, when this was open source, the interest level went up dramatically on the open source PDK. Now, I often get asked a question, does everybody have to open source the PDK? No, not necessarily. We certainly are cognizant or appreciative of the fact that, tremendous amounts of R&D dollars from a given company or foundry goes into this. So there's a notion of red IP and yellow IP. So red IP is effectively things that are designed in the latest and greatest technology node. And that probably most likely will stay as a three-way type of NDA. But I will note that N-way NDAs are a nightmare to complete. In fact, it may be an NP complete problem. You never really get there in linear time and space. So, one idea that I've been chatting with Mendy Firmenich about, with OpenPower is this idea of a unified framework for multiple parties to participate. Basically, kind of a yellow umbrella where different parties will sign the agreement, and that will give them access to the necessary IP. And of course, then that would be maintained on a secure server type of environment that would be acceptable to the IP provider. So I think that could be a great enabler to moving forward on some different advanced process nodes in a collaborative fashion. So summing up, what we're looking for is open collaborative platforms, whether it be in the architecture verification implementation space. CHIPS works closely with OpenPower and RISC-V, and we're certainly open to working with others on different types of IP implementations. In EDA, we work with Antmicro, eFabless, and some different universities that provide some of these different automation tools that we're working on in the open source community. Have continued partnerships in AI, ML, and then also in fabrication with Skywater and others. And of course, what open source IP really is about is enabling design reuse or interchange. It could be soft IP, it could be hard IP, it may even be something like chiplets, which basically is where you can build, so to speak, your winning hand by selecting different chiplet blocks to comprise your application and perhaps adding your own chip on top of that as part of that. But one thing I just want to say is relative to open source IP, it's really about building trust. In other words, if you pull something down from the internet, you want to make sure, have some degree of confidence that it's going to work for you, that there's not going to be problems. And of course, the software ecosystem has really done a great job of building this type of community and providing confidence. And some of that comes from discipline. And a difference from software with any particular IP is that what works at 20 nanometer may not work at 7 nanometer, as an example. So there's also that different aspect of the hardware ecosystem compared to software, that there are changes from process node to process node, and that does sometimes impact the applicability of a given software IP, or IP rather. Of course, hardware IP, it's about tape out, productization, confidence, and it's also the prevalence of cheap shuttles that is really helping to provide a proving ground for how to help move this forward. And of course, open sourcing PDKs really provides a democratization vehicle to allow different people to be part of the overall ecosystem. Let me just comment a little about open source EDA software. Part of it, of course, with building open source or building EDA software in general is technology access. Really, you'd require fundamental technology information to build that. So like you want to update your extractor, you want to update your static timer. You need to understand what the underlying SPICE models are, what the changes are to the cell abstracts, for example, or changes to the metal stack. And that type of information typically requires an NDA to accomplish that. And developers themselves, that's a unique mix of hardware and software skills. And it's really kind of a detailed knowledge of highly specialized areas. So these people don't necessarily walk down the street, so to speak, right? So it's a specialized skill, but that's an area that we definitely want to try to grow. And I think the open source community can help accomplish that because all the information is available. Correspondingly, testing, qualification, and QRR is still an important part of the overall EDA ecosystem, making sure that changes that are made are regressed properly and that QR type testing quality results is part of that development process. And of course, qualification of the foundry data, make sure that the extraction and timing, as an example, correlates properly at the field solver, SPICE level type of things. And then finally, methodology support. One thing that I get asked frequently in this arena is what is the support model for open source software? And thankfully, companies like Antmicro are stepping up to the plate and providing that type of support for the overall open source EDA ecosystem. So switching gears just a little bit. So a key question with all these chips coming out is how do we get more people to participate in hardware development? So in many ways, hardware developers And software developers, it's kind of like mixing oil and vinegar, right? Hardware developers sometimes are, called rocket scientists or mad scientists, if you will. And the software people, it's a happier ecosystem, right? Because if there's a problem, you can patch it and push it out, and it's not so hard. Whereas hardware, you push the tape out button, you're waiting months perhaps for the chip to come back. There could be a lot of money on the line in terms of the NRE or non-refundable engineering costs associated with that. So when you tape a chip out, generally speaking, you want to make sure it's right, and that's what's built into the culture. So some of this is a cultural thing between hardware and software, right? And trying to evolve that line of thinking, particularly from the hardware side, to consider different ideas and lowering those barriers. So this slide here really, I call making chip design more approachable, right? Which is hiding complexity and increasing productivity. So there's really two messages here. Of course, making chip design more approachable will encourage others to participate in the field and lower the barrier of entries, and making it so that people are less afraid to try this out. But it's also about time to market too. From an executive management perspective, you care about how quickly you can get your chip out to the market for the particular product that you're trying to build. So that's another part of it. And of course, we're seeing an evolution going from just transistors, which you still see in the analog space a lot, is hand-tuned, placed, and routed, to a gate-level representation, to different types of RTL reference or implementations. That could be an object-oriented approach, which we're seeing more so with Chisel, to system Verilog, where we're seeing quite a bit of adoption in the industry of that as well. And then finally, just going on over into actually building it, we see layout automation, logic synthesis, place and route, electrical verification. So the idea, again, is to increase productivity with less resource. But of course, the devil is in the details, and the fundamentals still do matter. You don't necessarily have to be an expert, but being conversant doesn't hurt. And then having the necessary guardrails in place will allow you to accomplish these goals. So just talk about building an engineering community, open source environment. How does it help? Well, it allows folks to see the whole picture. As I said, there's really you don't want mysteries. You want to eliminate or reduce silos that can help mature both hardware and EDA development. And of course, removing the legal barriers to collaboration is paramount to making this happen, excuse me. So collaboration between industry, universities, secondary schools. I think engaging students early is important to help show them how the big picture is, how things work together, and providing internships to students is a key part of that, right? It lets them see how their coursework or why it matters, right? And how that helps build things, right? So again, telling young engineers how they fit in the big picture. Funding research at universities is a good thing. I've had the opportunity to do that. I've had a chance to talk to university students, and it's always a great experience to talk to folks about that. And I think, as we were just chatting here with Kim, proactive mentoring is an important part in helping individual careers and their challenges, encourage publication, leadership, and speaking. So we talked already about this, so I'll just mention that one more time here. And then just some thoughts on what is the foundation of engineering? Well, it's people, of course. That's the bottom line, right? And there are many pieces to that foundation. But again, the idea is to build a community of different backgrounds needed to solve some of the most challenging problems, right? Having different thoughts, different perspectives really makes a difference in coming up with new ideas to solve these problems. So we really need to help build this community, and also to help encourage the knowledge of fundamentals. So just some final thoughts. So I think, as I mentioned earlier with Kim, it's like, I think quotas are an important metric, but that alone in and of itself is not going to help build that. We really need to help do this. We need to encourage math. We need to make it approachable, encourage science, help build curiosity, encourage folks to build things, try something out. If it doesn't work, that's okay. That's how you learn things, right? So I bake bread as an example, as a hobby. And sometimes, it comes out as a brick, right? But that's okay. That's how you learn, right? So the same thing. So the outcome of math, science, and curiosity are important things. You want to recognize and encourage different engagement styles. Not everyone approaches learning the same way. And you want to encourage shy and reticent individuals to participate, right? So, and then finally, I think establishing programs early in is important, right? To help build that curiosity, teach imagination and creativeness, and most importantly, encourage participation. So with that, I will conclude. So thank you.
Thank you, Rob.